Hello everyone. So today we would be discussing about the types of volcanic eruptions. First of all, what is a volcanic eruption? A volcano is a vent in the earth crust which allows the eruption to occur. And that eruption can be rocks, ash, lava, or some gases also. So this is like a vent or a pipe-like structure which allows the movement of the magma from beneath the earth towards the crust. So looking on the types of it, first one is intrusive. If it is intrusive volcano, it means that when the magma is rising from beneath the earth and it got solidified somewhere in the middle. So let's say it is rising from here and it got solidified here, then it would be intrusive in nature. And in case it rises up and comes outside, then that would be extrusive volcano. So now looking on the terms here, the first one is we need to differentiate between sill and dyke. Magma is rising from this point, let's say, and it rises up till the top. But while rising to the top of the earth, there may be some pre-existing rock structures already present. Let's say this is 1, 2, 3, 4, 5, 6. It has crossed all these type of rock structure and rises to the top. If it is dike, then it will disturb the pre-existing rock structures and would cross them. But if it is sill, it would not disturb the pre-existing rock structure. It would only be present at the horizontal place only. It won't disturb this type of rock structure. The pre-existing rock structure would remain the same if it is a sill, but if it is a dike, it will cross the pre-existing rock structures. Now, what is batholith? Batholith is the collection of the intrusive rocks as these are present here. Then what is lactolith? So if it is lactolith, then looking at the figure now, the movement of the magma from here to this region. Magma is collecting here, but there is no force to rise the magma further above. It means it's like a sill which do not crosses the pre-existing rocks. So if at some point the magma is not crossing above, this point can be called sill. But if the magma is coming continuously from some reason by the help of dike, then the rock structure of the above region would change like the shape of a dome. This magma forces it to change the shape. It do not crosses it, this magma do not crosses this structure, but it can force the pre-existing structure to change its shape so that it can be placed here. This magma can placed here. Like this is the shape change observed here. This is known as lactolith. But if we are observing a structure like this, just the opposite of this, magma is filled here, let's say here, and connected by some dike obviously, which is flowing the magma into it. So if this is the structure, it is called as lopolith if the shape is this. And if opposite shape, then localith. So this is how the main terms works in case of intrusive volcano. Sill, dike, batholith, laccolith and lopolith. If it is coming out, then pyroclastic deposits are also an important term. It is a collection of the gases and broken down rocks, ashes, which comes out and flows down the volcano. This move in this direction, like moving down from the wall. This they are coming with this dike and then flowing out this way. So in the next, we would be discussing about the extrusive volcano. And now the extrusive volcano. So the question is that why are there some volcanoes that are so explosive while the others are not? There are some reasons behind that some volcanoes are find out to be more explosive compared to others. So there are four factors behind that, and those are: first one is it depends that how much amount of gas is dissolved in the magma which is rising up, how much gas is dissolved in this magma. The second one is the viscosity of the magma rising. Viscosity plays a very important role here. The third one is the rate at which magma is decompressing while it is rising up, the decompression rate of the magma. And the fourth one is the number of sites where it is rising. Let's say it is one, it is more than one. So how many points are there from which it is rising? So these four factors plays a very important role in deciding that if the volcano is going to be explosive or not. So the first one is amount of gas, then if it is how much viscous it is, and the decompression rate of magma, and the fourth one is how much number of sites or point from where the magma is coming out. So first of all, we would compare the shield volcano and the cinder cone. So in case of shield volcano, we can see that there is only one vent, this pipe, from where the magma is rising. Magma is rising, gases are rising, pyroclastic material is rising up, and it is considered that the viscosity is lesser in case of shield volcano. Viscosity is less and amount of gases dissolved are comparatively lesser than the other types. So viscosity is lesser, amount of gases dissolved are lesser, and the decompression rate which is followed here is uniform, due to which the explosion do not occurs only at this point. The pressure difference at this point is not much. So that's why it is considered to be more uniform than other types, and the nucleation site is only one here. But if we'll compare it with the cinder cone, it will be like a conical structure. It is a like a dome structure, but the site from where the magma is coming out is one here. But in this case, in case of cinder cone, the decompression rate is not uniform throughout the journey. It is very less here, but while reaching here, the pressure difference is higher, due to which the explosion is very high in case of cinder cone. So as the explosion rate is higher here, viscosity is also a little more than the shield volcano. So that's why this explosion is more than shield volcanoes. Now coming on to the lava dome, a vent site is only one here, and viscosity is higher here. So if the viscosity of the magma rising up is higher, then what happens that this magma would be collected at this point and it would form a dome shaped here. Magma is rising up and the pyroclastic material or lava is not flowing down, due to which it is collected here and a dome shaped is formed here. The next one is composite volcano. It is considered to be very much dangerous as the decompression here is very high. The fissure eruption here is very high rate, and viscosity of the composite volcano is very high, which make it very much dangerous compared to the other volcanoes uh, here. Based on the explosive areas, this categorization is done. So in this categorization, we have six types. Those are Icelandic eruption, Hawaiian eruption, Plinian eruption, Pelean eruption, Strombolian eruption, and Volcanian eruption. The first one here is Icelandian eruption. It is of Iceland. So in this case, the fissure eruption, which is the molten lava which is erupting here, form the parallel fissures like this various parallel to each other. So they form lava plateaus in this region. So it leads to the formation of lava plateaus. As we have the example of Maharashtra, we can say a very long region in which number of eruptions has occurred at the same time, so which lead to magma rising from various places and lead to the formation of a plateau. So this way the fissure eruption occurs here. uh, it is not very much uh, it is not very much use rate. That's why it's like a shield volcano. Hawaiian eruption. In case of Hawaiian eruption, craters are also formed. Crater is, let's say magma is rising from this vent And when this magma has risen up, it will flow down. As the viscosity is less here, it will flow down to various sides on the dome. So later on, the circular path is left, that is known as a crater. This crater would be formed. And when this volcano is not active, then after the collection of water here by the rainwater and some other way, this crater would be converted into a lake, that is known as crater lake. Yeah. And the next one is Strombolian eruption. A Strombolian eruption is where lots of gases also erupts. So if the amount of gases is more, which makes the volcanic eruption more explosive. So yeah, in this case we have more gases, and the decompression rate is higher from this point to while it is coming out. So it makes it very much explosive due to the amount of gases more, and the decompression rate is very much higher here. So these type of volcanic eruption can be seen in Strombolian island. It is near Italy. The next one is Volcanian eruption. This is on the name of Volcano Island. It is near Stromboli. And in this type of eruptions, volcanic ash is also erupted. It's like the shield volcano type of structure. Yeah, and some cinder cones are also observed here. So the magma is erupting from single site, and the formation of the clouds and the ash is coming out also here, but the rate is faster than the rate we have observed in case of shield volcano. Now the next one is Plinian and Pelean eruption. These eruptions are very much explosive, and because of the eruption of pyroclastic flow in both of these cases. Pyroclastic flow is the rocks, the gases, the dangerous gases are also coming, and the minerals, and the rate of coming out of these lava and the gases is very huge, which makes this eruption much explosive than the other types. So these eruptions lead to very much large hazards also. So this is on the Mount Pele in the Caribbean island, which is a very hazardous volcano has occurred there. And the next one, that is Plinian. This is also very much hazardous. So volcanic eruption has occurred here. And this eruption also has some pyroclastic materials, lava flow, and the gases also. The rise up of the gases is very high. It's like it can reach to till the stratosphere. The gases can reach till the stratosphere. The pressure is such higher, which make this eruption very much hazardous. So that is all about the types of volcanoes. I hope you liked the video. Thank you for watching.